Hi, my name is Robin Dudrick. I'm a master's student at the Virginia Institute of Marine Science, and I study the fate of microplastics in coastal environments. I'm an environmental chemist, meaning I use chemistry techniques to understand what is going on in samples taken from the environment. I also consider the ecology of the systems I study and how humans impact those systems with our waste. This lesson, titled Microplastics Major Impacts Exploring Change in Seagrass Meadows, is designed for high school environmental science students based off my graduate research while using the Virginia Standards of Learning. This lesson focuses on feedback loops, using microplastic and seagrass as an example. In the included PowerPoint slides, the concept of a feedback loop is first introduced. Next, there's background on seagrass meadows and ecosystem components, such as abiotic and biotic factors, followed by an introduction to microplastics, including what they are, how they get to the environment, and why we should care. Finally, a detailed definition of feedback loops is given and the activity is introduced. Students will play a game to simulate what can happen to the health of an ecosystem when there's microplastic pollution. There are 5 phases per round: random event, management decision, inputs, impacts, and feedback loop check. The simulation includes random events and opportunities for players to make management decisions to show how both chance and human intervention play important roles in ecosystem health. Students will be prompted to fill out the data collection worksheet throughout each round of the simulation. The lesson plan, instructions handouts, and slides included all have detailed instructions on how to play the game. A demonstration round led by the teacher is highly recommended and included in the slides. The entire simulation can be teacher-led, or in advanced classrooms, the students can proceed through the remaining rounds at their own pace. The length of the activity can be modified for longer class periods by adjusting the number of rounds. Reducing rounds, however, is not recommended as it will be less likely for feedback loops to be apparent. Once the game is over, students will complete the graphing worksheet using the information from the data collection worksheet. Here, they will graph their data and answer reflection questions based on their outcomes. The game is designed so that groups will have different outcomes ranging from healthy, declining, or collapsed meadows. Because of this, it is important to leave time for discussion as a whole class. Don't forget to have groups share out the final health of their meadows and determine a class winner. The initial setup for this activity includes printing, laminating, and cutting out game cards, as well as assembling token kits for each group. The materials are easily accessible or can be substituted readily with whatever is on hand. All components, aside from student worksheets, can be reused. I hope you and your students enjoy this lesson, created as part of the Virginia Educators and Teachers Alliance lesson plan program at the Virginia Institute of Marine Science. If you're interested in more plastic-related lessons, check out their archive. And if you have any questions related to this lesson, please feel free to reach out. I loved connecting with students, and VIMS has an outstanding outreach and engagement team. Thanks for watching.